This problem and all other Calc 152 problems can be found here at Sarai Studies. Link is in the description box below.
Assuming you already tried U substitution and it didn't work out, this is an integration by parts problem because there's two things being multiplied together. So the first thing I do is set up my paper. So I draw a box and then split it into two. Why? Because there's only ever going to be two integrals every time we do integration by parts. So the formula is uv minus v du, where the v's are on the inside. Then I do uv du dv. So I start with limit. I ask myself, are there any logarithms here? No. Are there any inverse trig? No. Are there any polynomials? Yes, I see an x, so that's going to be my u. And then whatever is left is going to end up being my dv. Then du is the derivative of u times dx, so that's going to be 1 dx. Then v is the first integral we have to do, so it's going to be in our integral box over here. That's going to be the integral of dv. So that's the integral of cosine 2x dx, and here we can do a u substitution. So cup for a u sub, c is what we care about. I care about my u, my du, my dx, and sometimes my x. U is going to be my 2x. Derivative is 2 times dx. Dx is always du divided by whatever's here, so that's 2. Put everything in terms of u. So my integral is now cosine of u. Dx is now du divided by 2. Now everything is in terms of u. I see this as a constant, so I can take that out. So that's going to be a 1/2. And I'm left with this really nice integral, which I know, if you don't remember, Sarai, cosine, negative, down for derivative, opposite way for antiderivative. So cosine, antiderivative is sine. This is sine of u, 1/2. Let's see, because there's no bounds. And then p in cup is to plug your u back in. So we have 1/2 sine of, our u is 2x, plus c, and that is our v. We don't care about the plus c's because at the end of the day, there might be 5,000 plus c's, but at the end of the day, you're going to have only one plus c in your answer. Now that we have everything that we need, let's get into the equation. So we have u, which is our x, times v, which is 1/2 sine of 2x, minus the integral of v times du, which is just dx. And then this right here is the second integral, and we're going to solve that in the second integral box. But before I do that, I like to drop everything down. So this is really x sine of 2x divided by 2, and then minus whatever I get here is going to be plugged in here, and I'm going to make sure I don't forget my plus c. Now I can solve. Here there's a constant, I can move that to the outside. Then I can do a u substitution. That's cup. C is what we care about. I care about my u, my du, my dx, my x. And honestly, this is another reason why I do the boxes, because you don't get confused, because here we did a u sub, here u was 2x, here there's another u, and then we're going to do another u. So when my professor's looking at my paper, they know that this u is only about this problem here in this box. This u is only about this stuff here. This u is only about this stuff here. So everything is contained and it's very clear where everything is and you don't get confused. So here the inside is 2x. So I'm going to make that a u. Derivative is 2 times dx. Dx is du divided by whatever is next. 2 dx, so that's 2. U is put everything in terms of u, so that's going to be 1/2 sine of u. Dx is now du divided by 2. So now dx is also in terms of u. This is a 2, or really a 1/2. Pull that outside because it's a constant, so that's going to be 1/4. Then I can find the antiderivative of this. Sarai, cosine, negative. Down for derivative, opposite way for antiderivative. So sine this way, the antiderivative is negative cosine of u, 1/4 plus c. And the p is to plug your u back in. So we have -4 cosine, and our u is 2x plus c, and this is the integral of that. Now this is our answer, but we can simplify a little bit further. This is x sine of 2x over 2 plus cosine over 2x over 4. Negatives turn into a positive, and plus c. And that is your answer.